Good afternoon, students. Good afternoon, students. We will commence today's class with separation of mixtures and purification of chemical substances. I believe I can go on.
Yes, please.
Hello? I can move on.
Yes.
Okay, good. Talking about separation of mixtures. So before we go into detail about this topic, we'll have to understand some concepts about mixtures. So let's start with pure and impure substances. A pure substance, as far as chemistry is concerned, for a substance to be pure, that substance has to be made with only one substance and has no other substance mixed with it. For example, let's say element, for example, if an element of oxygen is a pure substance. Ozone, for example, we have ozone layer, which is made up of 3 molecules of oxygen. It contains only oxygen. So the fact that it contains only oxygen makes it a pure substance. Another example of pure substance are water. Water is a pure substance. It contains only hydrogen and oxygen. So these are examples of pure substance. But for impure substance are those substances that contains mixture of a pure substance and impurity. Example is salt and water. So if you have a salt and water as a mixture, it becomes an impure substance because we're having two different substances in it. Water can be the pure substance and salt can be the impurity. Salt can be the pure substance, water can be the impurity, can be the impure substance. So that is that about pure and impure substance. There are some differences between pure and impure substance. Some pure substance are those substances that they melt at a specific boiling. They melt. They have a specific melting point and a specific boiling point, but impure substance does not. That's one difference. Another difference is that pure substance gives a single spot on a paper chromatogram. Now, as we move forward, you understand what a paper chromatogram is before the end of the class. Why? For impure substance, they give different spots on a paper chromatogram. Another difference is that pure substance have a specific density. Why for impure substance, they don't have a specific density? This is because that for impure substance, there are many substances in it. So one substance will have its own density, another substance will have its own density. So it will be difficult for an impure substance, it's even impossible for an impure substance to have a specific density or specific melting point or boiling point. I believe you understand that. Now, test for impurity. The purity of a substance can be tested just by getting the melting point or boiling point. For example, water. The boiling point for water is 100 degrees Celsius. So if you have a water and after boiling it, the boiling point does not occur at 100 degrees Celsius, it tells you that that water is containing impurity. That's some impurity in that water. So that is how you are able to test maybe a substance is pure or not. Ethanol, for example, the boiling point for ethanol is 73 degrees Celsius. So if you boil an ethanol and it's boiling, it does not boil, its boiling point varies. You realize that its boiling point is not at 73 degrees Celsius. That shows that ethanol is containing an impure substance. Any question on this? Now, I believe you are hearing me. I believe I'm audible enough.
Yes, I can hear you very well.
Now, element. That moves to the other part, which is element. Elements are substance that cannot be splitted into any chemical method. That cannot be splitted by any chemical methods. Example, chlorine, oxygen. The air we breathe in oxygen. So oxygen is an example of an element. It cannot be splitted by any chemical means. If you have an atom of oxygen, you can't just split an atom of oxygen by any chemical means. Before we can split such, maybe you have to talk about nuclear chemistry. But for an ordinary chemical process, an element cannot be splitted. So we have about 118 elements, which some are discovered through radioactivity, some are discovered by just from natural, just natural occurrence. While some are produced artificially. Not all are natural occurrence. Some are produced artificially. Well, and these elements in chemistry, they are symbolized. Elements, they have their own specific symbol. This symbol was done by John Jacob Berzelius in the year 1914, the year 1814. That was the year elements were given symbols. So each element have their symbol. So there are actually 4 principles guiding the way elements are being given their symbol. The first one is the first letter of that element. That's the first principle, using the first letter of the element. Example, we have hydrogen, we have boron, we have carbon. So you realize that this element, that symbol, is just the first letter. So we also have other elements also. The second principle uses the first letter and the second letter, that's the first 2 letters. That's what the second principle uses in order to give element their symbol. Example, beryllium, for example. The symbol is Be. That's beryllium. Lithium, for example, the symbol is Li. So these are elements that their symbol is derived from the first 2 letters. We also have elements that for the third principle are those elements which their symbol is derived from the first letter and any other letter in the element. For example, let's say chromium, for example. Chromium, for example, the symbol is Cr, which is the first letter and the third letter. Also have manganese. Manganese, for example, the symbol is the first letter and the third letter. Now, the fourth principle uses the Latin name of the element to give it its symbol. For example, let's say sodium, for example. Its Latin name is natron. That's why its symbol is Na. We also have silver, which its Latin name is argentum. That's why its symbol is Ag. We also have iron, which its Latin name is ferrum. That's why its symbol is Fe, and etc. So these are the ways elements are being symbolized. So in chemistry, elements have their own definite symbol. Now let's move to classification of elements. Elements are classified into metals and non-metals. They're classified into metals and non-metals. Metals are those elements that ionize by loss of electron. As before they become ionized, before they become electrically charged, there's a need for such elements to lose an electron. Example is sodium, is a metal. Iron is a metal. Aluminum is a metal. So before sodium can become ionized, it has to lose an electron. So such elements are referred to as metals. We also have non-metals. These are metals that they gain electron to become ionized. Example is chlorine, oxygen, sulfur, fluorine. All these elements, they gain electron they gain electron before they become ionized. Chlorine, for example, before it can become ionized, before it can become electrically charged, it have to gain an electron. then becomes electrically charged. So such elements are regarded as non-metals. But in the case of hydrogen, there's a kind of, you can't actually see maybe hydrogen is a metal or a non-metal, but in most cases, it's categorized as non-metal. But it also it can also behave as a metal. So this brings us to metalloids. We also have elements that are referred to as metalloids. These elements can possess the characteristics of metals and that of non-metals. For metals, they ionize by loss of electron and at the same time ionize by gain of electron. Such elements are referred to as metalloids. Example, silicon, germanium, vanadium, some elements under transition metals. So they are referred to as metalloids, having both characteristics of a metal and that of a non-metal. So that's why we have a traditional metal charts for PowerPoint, where the blue are for all the metals, the yellow for the non-metals, the green for the metalloids. So this is just for you to be able to understand and know those elements that are metals, metalloids, and non-metals. Now this brings us to a compound. Don't forget, elements and compounds are pure substance, but mixtures, not in all cases, is regarded as a pure substance. Mixture is regarded as an impure substance. Now for compound is a substance that contains two or more elements chemically combined together. Now for every compound, they must be combined chemically. There must be a process of a chemical bond before a substance can be referred to as a compound. And in most cases, compound, the constituent of a compound, the property of the constituent of the compound differs from the compound itself. That's compound for you. The properties of its constituent differs from compound itself. Example, water. This is something we use every day. So water contains hydrogen and oxygen. So this constituent, the property of hydrogen and oxygen is different from the property of water itself. You have sand also, which is made up of silicon and oxygen, SiO2. So this also, the property of silicon and oxygen differs from the property of sand. So these are the properties of compound. This brings us to mixtures. Now, mixtures are impure substance in most cases. Though we can have a mixture that is impure, that is having only one substance, but mixtures are impure substance. Now, so mixtures are those substances that contains two or more constituents which can be separated by physical methods. Mixtures can be separated by physical methods. Compounds cannot be separated by physical methods. An example of a mixture, our air. We can see that in our air, we have so many elements and compounds in our air. We have the oxygen, we have the carbon dioxide, we have nitrogen, rare gas, dust, moisture. So these are the constituents of air. So for every mixture is definitely a constituent. And this constituent, the property of this constituent makes up the property of the mixture, which differs from that of compound. Then the property of compound, the property of the constituent of compound differs. But for mixture, all the constituent makes up. For example, let's see more example of mixtures. We have soil. For the concept of soil, we have clay, we have sand, we have humus, mineral salt, water. All these are constituents of soil. Our urine is also a mixture. Our urine contains urea. Urea is a chemical compound, which is part of the constituent for urine. So urine, you have urea, water, mineral salt. These three things makes up the property of urine. So this is the property. These are how mixtures. This is the constituent of urine. Now let's talk about the difference between compound and mixture. Compounds and mixture. The difference between compound and mixtures. Compounds, the constituents of compounds are present in a fixed proportion, unlike mixtures. For example, let's say water, for example. Water contains 2 molecules of hydrogen and 1 molecule of oxygen. That's what makes it in water. So if you have a substance that contains maybe 3 molecules of hydrogen and 1 molecule of oxygen, is no more water. So what makes it a compound is because the constituents in it are in fixed ratio. It can never change in eternity. It can never change. Water, for we to have water, we need 2 molecules of hydrogen and 1 molecule of oxygen. Look at our common salt, for example, sodium chloride. Sodium, 1 molecule of sodium, 1 molecule of chlorine. Fixed, it's fixed, does not change. But for mixture, for mixture, the constituents are mixed in any proportion. They are mixed in different proportion. The air, for air, we are only giving the percentage. That is, there's a difference. It's not specific. So we can say of our air, we can say the percentage of the constituents of those substances that makes up the mixture. But the constituent itself are not specific. We can't actually say this. We need only 2 oxygen to make up the air. No. So that is a difference between compound and mixture. Another difference is that the compounds are joined by chemical bond. There must be a process of chemical bond what can be called a compound. For mixture, no presence of chemical bond. We also have another difference is that compounds are always homogeneous. That is, when we say homogeneous, it means that that compound contain that they follow the same form. All the substances in that compound are in one form. But in the heterogeneous mixture, homogeneous mixture are mixtures that the constituents are of the same phase, they are the same state of matter. While heterogeneous mixture are those mixtures that the constituents are of different states of matter. We also have constituents of compounds. Another difference, constituents of compounds that cannot be separated by their physical means. That is, the constituent of compound, you can't just separate it by physical means. No. Sodium chloride, you can't separate it by physical means. But for mixtures can be separated by physical means. Another difference is that compound are entirely the properties of, I've said this before, the properties of compounds differ. The properties of the constituents of compounds differ from compound itself. While for mixture, the property of the constituent of mixture makes up the property of the mixture itself. Now, this brings us to separation techniques. You know, we've discussed about mixtures, compounds, and etc. Now, this is to enlighten us about separation techniques, mixture itself, the basics. I believe with this we can say something about elements, compound, and mixtures. Now, separation techniques. So these are techniques that are used to separate a mixture. There are techniques used to separate a mixture. So for separation techniques, there are physical methods that are used to separate one mixture from another mixture. These techniques cannot be used to separate a compound, as I've said before, the difference. You can't use these techniques to separate a compound. They are to be utilized to separate mixtures. And for chemists to have a pure substance, that's why these techniques are being utilized. For chemists to have a pure substance, they have to separate it. Imagine having urine mixed with water. So as a chemist, you won't find it difficult than to just separate the urine from the water in order for you to use the water, make the water pure. So let's start with the first one here. The first one here is sieving. For sieving is a method that is used to separate insoluble mixtures. Yeah, it is used to separate insoluble mixtures. Be specific, it is used to separate solids, two different solid particles. So this process is very, very easy. It's something most of us utilize even in our day-to-day activities. You just need a sieve. Then the mixture you want to separate is being poured into the sieve. And for every sieve, there's always hole. Then there will be a mesh under the sieve. So the solids with larger particles stays in the sieve, while the solids with the smaller particles pass through the sieve and go to the mesh. And this is how this separation is being done. So this separation is usually done in the production of gari, usually done in the production of gin. Also. So this method is applied in mining industries also, in mining industry, and also in making gari. So that is sieving. Sieving is very easy. So something we indulge in, even in our day-to-day activities. We can just take water and we can just take sieve. It's the sieve in our environment, and you just sieve what we want to separate. Now, magnetic separation. This is another method in separating techniques. So as the name implies, magnetic separation is used to separate magnetic particles from non-magnetic particles. For example, when we have an iron filling with sulfur together in a mixture. So to separate this, a magnet is being introduced. So immediately a magnet is being introduced to the magnetic particle and the other particle there. So the magnet attracts the magnetic particle to itself. So by so doing, the magnetic particle is being separated. As I said before, iron filling and sulfur. So if magnet is introduced to such mixture, the ion will be attracted to the magnet and separation occurs. So that's how magnetic separation is done, and it's a method that is used in steel industry. The method is also used to separate tin from its tin ore. That is, in most cases, to separate magnets from their ore. Another separation method is sublimation. So sublimation is the conversion of a solid to gas. That's the main definition for sublimation. So it is a method that is used to separate substance that sublime from substance that does not sublime. For example of substance that sublime are iodine, ammonium chloride. These are examples of substance that sublime. Solid carbon dioxide, that is dry ice. These are examples of substance that sublime. So to separate such substance, maybe you have a mixture of iodine and sulfur, or iodine and sodium together in a mixture. So in order to separate this, heating is applied. Heating is applied to the mixture, and the substance that can sublime will evaporate, turning into gas. Then the gas is being trapped using the condenser. So that's how sublimation is being done. Now for decantation involves the separation of insoluble solid in a solution. So the solution of insoluble solid in a solution. For example, let's say we have like sand in water. I want to separate the sand from the water. So what is being done is we allow the solution to stand for some minutes. Then we have the upper layer and the lower layer. Then the upper layer is being decanted. That is, the upper layer is being poured out from the solution. And by so doing, we have our upper layer, which is the pure part, and we have our lower layer. So decantation is just utilized to separate insoluble particles in a solution. We also have centrifugation. Centrifugation involves the use of a centrifuge. Centrifuge is a machine. In most cases, where you can find centrifuge are hospitals. You can definitely find centrifuge at hospitals. So it is usually used to separate tiny particles, or let me just say insoluble particles in a solution. So to separate this mixture is poured in the centrifuge tube or test tube. You can call it test tube or centrifuge tube. The centrifuge tube is placed inside the machine. Then immediately the machine is ignited to start working. Then the centrifuge spins. There'll be a spinning. So after the spinning is being done, these particles will now form two layers, an upper layer and lower layer. Then the upper layer is being decanted out in most cases. But when it's also used in the hospital, especially trying to remove some particles from the blood particles from plasma. So it's usually used in hospital as a centrifuge. So this other type of separation techniques is, for example, you can see the image there. So that machine, as you can see the image there in bottom of the slide, the machine there is the centrifuge. Another type of separation technique is filtration. Filtration is very, very simple. It is used to separate, it's also used to separate insoluble particles from solvents. It's also used to separate insoluble particle in a solution. Example, let's say a solution of water and chalk particle. So in a solution of water and chalk particle, filtration is the best method that I will use to separate such. So you know the chalk will mix with the water. It won't mix completely, so because it is an insoluble particle. So to separate this, a filter paper is being used. So the filter paper is being inserted into a funnel, and the funnel is placed on a beaker. So the mixture is poured inside the funnel that contains the filter paper. Some of the mixture will go inside the beaker, while some will stay at the filter paper. So the part of the mixture that stays at the filter paper is referred to the residue, while that part that stays at the beaker is referred to the filtrate. So that's how filtration is being done. And filtration is usually used, especially in our car, the filter pump in car engine. The process is filtration. For every car, there's always a filter pump there in the car engine. So that process by which the filter pump filters in the car engine is filtration. So this is where filtration is being applied. And there are also other cases also. Evaporation. Evaporation is also called evaporation to dryness because it is used to recover a solid solute from a solution, while the solvent in that solution is being sacrificed. So what really happens is the solution that contains the solid solute is heated using an evaporating dish. So after the heating,
Hello, sir.
the solvent will evaporate, leaving only the solid particle in the evaporating dish.
Hello, sir. You have about 8 minutes to go.
Sir?
You have 8 minutes to go.
Okay. I'm already rounding up. So this method is used for substance that contains high melting point. So substance that contains low melting point, it is wrong to separate such substance using evaporation, because the solid particles will also evaporate with the solvent particle. Let's move to distillation. Now, for distillation, is used to obtain a pure solvent that's in a solution in which the solvents are of far boiling point. That is, the boiling points of all the solvents in the solution are that differ in a very large amount. That's when distillation is being used. So for distillation to be applied, they use a distillating machine, and a Liebig condenser is used. So in this case, the mixture is poured in the machine, in the apparatus, in the distillating apparatus. So when that occurs, the mixture is then allowed to evaporate after heating. Then the gas are trapped in the condenser, which is then converted back to a liquid substance. That's how distillation is being done. But for fractional distillation, this method is used for separating two or more miscible liquids. And liquids are miscible. When we say the liquid is miscible, it means that liquid, they can mix with each other very well. That's meaning of miscible. But in this case, what makes this one different from distillation is that for fractional distillation, a fractionating column is attached, and is only used for solution that contains closer boiling points. That are boiling points are not that far from each other, maybe just 10 degrees Celsius difference. So in the process of fractional distillation, so the solvents are being fractionated out from the fractionating column, and each solvent is being recovered. So this method is used in crude oil. Crystallization is also used to separate salt which decompose easily. I said before that for evaporation, you can't use salt that decompose easily to separate evaporation. It doesn't work for evaporation, because in the process of heating, the solid will also evaporate because it decomposes easily. But for crystallization, this is the method where those salts that can decompose easily are being separated. So it is used to separate solid particles that decompose easily. So in this process, heating is applied for a little amount of heating is applied, not little amount. Then after such, then the solvent is left for some minutes to cool. It cools for some minutes. Then after the cooling, then these crystals are now this crystal will now contain water particles. So the water particle present in these crystals are referred to as water of crystallization. For example, 6-pentahydrate. All these are water of crystallization. But a salt that does not contain water of crystallization is known as an anhydrous. Contains water of crystallization is known as hydrate. That's about fractional crystallization. That's about crystallization. Now, fractional crystallization is also used to separate two or more salts. Two or more salts are being used to separate fractional distillation. So the only difference there is that a fractionating column is applied, being done, and we have chromatography. The chromatography is just used to separate solvents that can move through a absorbent medium. That's where chromatography is being used. So it is used to separate all those constituents in a mixture that a solvent and an absorbent medium. Now, in this process, we have paper chromatography, ion chromatography, thin layer chromatography, etc. But the most popular used one is the paper chromatography. So in paper chromatography, we just put the mixture, and the solvent is usually ethanol, methanol, etc. So where the mixture is in the container and the absorbent medium is there, then the liquid will move and create like a point. So if the liquid is creating more than 1 point on the paper absorbent, then such liquid is an impure substance. But if it has only 1 point on the paper absorbent, such liquid is a pure substance. So we'll come to the end of today's class, and I will expect question. Is there any question? Hello? Are you still there? Hello?
Yes, sir. Yes, sir.
Are you still there?
Yes, sir.
So we've come to the end of today's class.
Oh, okay. Okay.
Did any